Hey, folks, welcome back to the Routing Loop. I'm joined here today by two good friends of mine, Christian and Steve. We are continuing our series of the recap from doing the Chalk Talks from reInvent 2024. And today we're talking about bringing your own networks to AWS. And of course, if you guys are looking for any upcoming episodes or if you missed any episodes, don't forget to hop on over to theroutingloop.net where you can find all that information and some information on our guests and our hosts today. But now I want to kind of introduce our guests, Christian and Steve. Christian, who are you and what do you do at AWS?
Hi, my name is Christian Nelson. I'm a manager for Specialist Solutions Architects. So I manage a team of networking and security specialist SAs, and I'm based in San Francisco.
Nice. And Steve, you're a tech leader. What does that mean?
I am. So yeah, I'm Steve Seymour. I'm the tech leader for solutions architecture and networking. So I look after what we call our technical field community inside AWS. So everyone that talks to customers about networking is part of that community. And I'm the tech leader in that space.
Awesome. And it's been a while since you guys have been on the show, right? I haven't, unless of course you guys, dare I say, went with another host other than me.
For me, it's definitely been a little while, yeah.
Yeah, cool. All right, so what are we talking about today, gentlemen?
Yeah, so this, as you said, this is a rerun, if you like, of the Chalk Talk that Christian and I did at reInvent, and it's all focused on bring your own networking, and by that we mean bring your own IP addresses and bring your own AS number, your autonomous system number. And I guess the format of this session is a little bit different. We have a full live demo of the process of bringing your own IP addresses and your own AS number into AWS. So we have a set of resources that we're going to be using. So that's the goal of this session. We'll take you through the concepts behind it and then actually walk you through the process end to end. So yeah, we're going to show you what we've got.
Nice. So Christian, did you pray to the demo gods to make sure everything would go okay?
Definitely, knock on wood. It went well at reInvent itself, so let's hope that it goes well today.
Cool. So without further ado, I'll bring up your presentation, Steve, and why don't you go ahead and kick it off? Just want to say hello to Dominic. He actually attended your session, I guess, and he was really impressed. So kudos to you guys on that. Yeah, let's get going.
Yeah, so it's interesting talking about bringing your own networking to AWS. One of the focuses in this session will be around BGP. Christian and I have spent a lot of time talking about DNS and BGP, haven't we, Chris?
Yes, definitely. And it's kind of like the two topics that you would need either one of them to like really cause a global outage. So I guess it's like whenever you need a global outage, it's either Steve or me.
Yeah, so don't blame us.
It's never DNS, it's always BGP, right?
Yes, let's go with that one. So yeah, this is the kind of path through the session that we're looking at today. We're certainly going to have to explain a few acronyms. I'm going to assume that there's some people here who have a lot of experience in this space, and perhaps some of you who don't have quite so much experience. So we'll give you a bit of background there, explain the acronym soup, as it were. We're going to talk about where we can start from, which is, in this case, an AS number that we have for this particular demo. It's specifically assigned for this. It's not another Amazon internal AS number, an Amazon set of IP addresses. These are a set of resources that we can use that are effectively outside the Amazon world, and we're bringing them in just like a customer would. So we'll look at where those are registered. So we'll look at the regional internet registry and see where those resources are. We're then going to talk through the process itself. And as you can imagine, there's quite a bit involved in this. And it might be interesting to you to see the split between what you have to do on the AWS side and what you might have to do in the case of the resources we're using here with ARIN, who is the regional internet registry that we're going to be using. So we'll then look at what you need to do to prepare all that. We'll bring it into AWS and introduce it into IPAM. So this is the tooling that you're going to see, the IP address management tooling. And at the end of it all, hopefully, if we have enough time, you can check our work. So you can actually see what we've done throughout the session. So that's kind of the plan of where we're going to go with this. So that acronym soup. So we thought we'd just list them out here. You can read what's on the screen here, and we're quite happy to share these slides if you haven't got them. But the key terms you're going to hear us using throughout this session are ASN. This is an autonomous system number. It identifies a particular network on the internet. It usually is aligned to an organization. So in the case of Amazon, we're AS 16509. We do have a couple of other AS numbers that we use for specific things. And there are actually some organizations out there who have multiple AS numbers. But the intention is it identifies a particular network or a network of networks. Obviously, in the case of AWS and Amazon, we have multiple pieces of our network, but we identify all of it as AS 16509. We're going to be talking about prefixes. In the context of this, a prefix is a contiguous block of IP address space. That can be IPv4 or IPv6. And it's important to say that in this session, we're actually going to be looking at both v4 and v6, because customers can bring their own v4 and v6 address space into AWS. So if you look at the example here, you're probably familiar with the Google public DNS resolver that sits on 8.8.8.8. Well, the prefix that sits within and that is advertised on the public internet is 8.8.8.0/24. That's the prefix that identifies it. BGP, probably one of the oldest protocols on the internet and still going strong and being used and abused in many different ways. BGP, Border Gateway Protocol, it is the protocol that is used for exchanging reachability and routing information between different ASs, so the autonomous systems that I mentioned at the top of this slide. It's an exchange of information that says, hey, I've got these IP addresses and you can get to them via me, and I will listen to what you are going to advertise and make decisions for my own routing based on what you advertise to me. The last two here are kind of perhaps less well known. ROAs, Root Origin Authorizations. This is, I guess, relatively new in the scheme of the internet, but it is a way of signing those advertisements. So if you imagine that I have a block of IP addresses and I'm going to advertise them to my peers using BGP, you might want to validate that I'm allowed to advertise those IP addresses and attract that traffic. You've probably come across or heard of in the past situations where blocks of IP addresses have been hijacked by other network providers, intentionally or unintentionally, as most of the cases are. So ROAs are a way of signing those advertisements so that people can trust, hey, this block of IP addresses should be advertised by this autonomous system. And if they see an advertisement from someone else, they can choose to ignore it and not install that route into their routing tables. And then finally, the Internet Routing Registry for Routing Policy Specification Language, so RPSL. This is the more traditional way of identifying which networks have which blocks of IP addresses assigned to them. And there are registries of this information. People then pull that data and use it to filter what routes they would accept. But the problem with these entries in the IRRs is that actually it's relatively easy to create an entry for any block of IP addresses against any AS number. So it doesn't have that strong authentication or signing process that ROAs have introduced into the modern internet, if you like, in terms of routing. So you're going to see a few examples throughout this session where you can go and look at what we're actually doing. So obviously, this is a little bit different to what you would see at reInvent. This is a screenshot of an example of what you would have seen if you were sitting in the room at reInvent. You can scan that QR code and it will load the Hurricane Electric set of BGP tools. And straight away on the screen that you hit when you first go there, it will tell you what is your IP address, what it is announced as in terms of the prefix that you're coming from, and the AS number that is being used. So that will normally identify your ISP. The other thing you can do is go and have a look on what's called the Super Looking Glass, again, within the Hurricane Electric BGP toolkit. And you can actually see a bit more information from the perspective of a set of nodes that are out there that monitor all of these different BGP announcements. So in this case, what we're looking at here is a node that happens to be sitting on the AWS infrastructure, so where it says neighbor there. And it's saying the path that you would take in terms of autonomous systems to get to this prefix, so 3.80 in this case, is via these two AS numbers. And you might recognize that 16509 from what I said earlier. That is the Amazon AS number. So you can actually go and dig into this information yourself. Many people haven't had a look and seen kind of where their IP addresses are coming from, how they're being advertised. The tools are all out there, and you can go and have a look at the ones that we're going to be using for this session as well. The other thing that you can go and validate are the ROAs, so those root origin authorizations. So this is where you can go and see, is a particular prefix allowed to be advertised by a particular AS number? And in this case, we're using Cloudflare's RPKI toolkit to do that. The QR code that you can see there will take you to the tooling. And you can see that if we put in the 3.80/12 prefix and we say, can that be advertised by AS16509? In this case, yes, it can. And the other piece that's embedded in that information is how specific can that advertisement be? So in this case, the question that I asked was, can this /12 be advertised? Well, it can, but it can be advertised right the way down to as small as a /24. So a much smaller block, a more specific block of IP addresses. And the ROA contains that information as well. And an important thing to note here is that the way that AWS looks at these BGP advertisements and ROAs is that we have signed all of our advertisements. There's a blog post referenced there at the bottom. But AWS has signed every single one of our routing advertisements so that other ISPs and other networks out there can validate that these IP addresses should only be coming from an Amazon AS number. Equally, when we receive announcements from our peers, we validate whether there are ROAs in place for those. And if they don't match, we drop them. So this is a very important way that we're all helping in terms of internet security. And if you're interested in learning more about that, I would go take a look at that particular blog post. So we've talked about the idea that we're going to be bringing IP addresses, bringing AS numbers over to AWS. And what we mean by that is you're taking resources that perhaps you already use in an on-prem environment, have been using perhaps for many years, or maybe relatively new, you've acquired some IP addresses, and you're going to bring them over to be able to use them on your AWS resources. And that could be as simple as an EC2 instance that you want to bring over a particular IP address for because it's something that you're unfortunately very tied to. You can't change it. It could also be because you've built up a set of reputation, a background based on these IP addresses. We see this as being quite common in the past for things like mail sending services. We have customers that have worked very hard to maintain a good reputation for their IP addresses, and they want to continue to use those whilst moving their workload onto AWS. The simplified migration side of things is where if IP addresses have already been used for those workloads, there are certainly some customers out there who, for no fault of their own, are stuck with having to use certain IPs for endpoints perhaps, or they're allow listed to reach out to other pieces of infrastructure. They need to come from a particular source IP. They can migrate those workloads and keep the same IP addresses for those particular implementations on AWS. So that kind of ties together the migration and the hard-coded legacy dependencies. Definitely the allow listing case is one that I come across quite a bit. I speak with customers where they have spent many years getting their IPs allow listed for other services, and they don't want to go through the pain and process of changing that. The other side of things is there's definitely some compliance and regulation situations where IP addresses that need to be identified as belonging to a particular company, and it's not acceptable in those situations that IP addresses would show up as being owned by AWS. I mentioned IPAM, so IP address management. We're going to be using the Amazon VPC IPAM service as part of the demos we're doing here. There are two variations of IPAM, and we just want to be transparent here and share this with you. There is the IPAM free tier, which completely supports the process of bringing your own IP addresses into AWS. It gives you the capabilities quite clearly listed on the left-hand side there. However, for this demo, because we want to be able to show you across multiple regions, and we want to be sharing IPAM pools and a couple of other capabilities, we're actually going to be using the advanced tier as part of this demo. But you can bring your own IP using the free tier.
All right, so with this, let's have a look at what we actually have for this demo. As Steve mentioned before, we wanted to show you a real demo from the perspective of a customer. So we needed an IP space or a set of IP space as well as an ASN that is actually outside of AWS, where we can show you how to do this process. Well, both Steve and I have our own ASNs and our own set of IP addresses. We figured it's probably a better idea we use something for specifically this demo. So we managed to get from our IP management team internally within Amazon one ASN and 2 sets of IP prefixes. So if you scan the QR code, you can actually see within the Hurricane Electric service, this is the ASN, the 401396, that we have set aside for this demo. So it's completely outside of anything that Amazon usually does. It's purely an ASN for this demo. And later you'll see the prefixes, so they're currently not listed on the website from Hurricane Electric, but we also have one IPv4 and one IPv6 prefix. So with this, let's have a look how they actually set up. If you can go to the next slide. Next one.
Do you have to give those back?
We're gonna keep it for now, but we're gonna use it for internal training. So for now, we can keep it.
That's awesome.
So just to explain kind of like where all this comes together. So there are so-called RIAs, regional internet registries. They get IP address space from IANA, and then they distribute it, and then there's like different levels below there. So some RIAs have like LIRs, local internet registries. Below them, some have NIRs, national internet registries. So you usually get your IP space as an end user either from a RIA, like ARIN, RIPE, APNIC, or a local internet registry, which is usually common in Europe, or a NIR, a national internet registry, such as in Japan or India. At this point, we basically support all of them through different mechanisms. We're going to show you the RIA ARIN because that's what we got, and that's where our IP space is. So when we actually show you what you do inside of the RIA, that differs from what it might look like for you. So for example, I have both ARIN and RIPE space, and while the concepts are the same, the portals and all of that looks quite different. So with this, if you could switch over. So here's an overview. These are the prefixes that we actually have, but I'm going to show it actually in the real portal. If you could switch over. Yeah, perfect. All right, so here's again the Hurricane Electric side that you saw earlier with our IP space, but let me actually switch over to the ARIN portal where I'm currently logged in and show you what we got. So this is how you would manage your IP space and your ASNs within the RIA. So as mentioned here, it's ARIN. And you can see here is our ASN. So if I click on this one, it shows me my ASN, pretty much nothing else right now. We're going to come back here later because there are certain things that you can do in this record set. You can like add a common field, which we will need. The other thing that we have is our IP space. So we have, as mentioned, 2 networks. So we have here our IPv6 network, which is a /40, and we have an IPv4 network, which is a /23. So that also allows us then to split it up and do some nice subnetting. I'll later come back and show what is exactly done here, but what we have done for now, we've just set up the reverse DNS. So you see here reverse DNS information. Anyone who has ever set up a domain that looks familiar, except that it's for the reverse zone, which is listed here. And we have delegated it to Route 53. You don't have to use Route 53. It's obvious why we use Route 53 because we got it. If you use another DNS provider for your reverse zone, it works exactly the same way. But we'll later show you there are 2 different methods of how to authenticate the IP space, and one of them uses reverse DNS. So that needs to be set up. That's pretty much it that we have in the setup of our RIA. And with this, let's go back to the slide deck, and then Steve will explain to you of how we're going to choose to use our IP space.
Yeah, so if you wanted to grab a screenshot or make a note, these are the resources that we're going to be moving as part of this process that you're going to see. So let's leave it there for a second. Okay, so what we're going to do first of all is we are going to take the entire /23 of v4 address space, and we're going to bring it over into AWS. We're going to bring over the /40 for the v6 space. We will need to attach a rower to the 23 and the /40. So we need to confirm that we are able and authorized to be advertising this address space. A typical use that we see where customers have blocks of IPv4 address space, in this case, the /23, is they will then divide that between different AWS regions. So the smallest that is supported from an IPv4 perspective is a /24. So we're going to allocate a /24 to one region and the other /24 to another region. So you'll see that as part of the process. We're also then going to split the IPv6 space down into /44s for each AWS region involved. You could go down to a /48, but we're going to be looking at this from a /44. So this gives you an idea of how you can divide up the address space, and this is how we're going to approach it for the rest of this session. So what's the process we're going to be going through? So there are 4 key steps to it. The first thing is that we have to prepare all of the resources that we're going to be moving. We need to be able to verify that we own this IP address space, and then we have control of the AS number that we're going to be bringing in. There's a couple of different ways that we can do that. We're hopefully going to show you both of those for different elements of the process, just so you see them. One of them is by creating an X509 certificate that can then be uploaded onto the public listing for these resources. So publish it at the IRRs. And you'll then be able to have a look and see that the signature we've put up there is completely visible to everyone. But if you hold the private key, which is how this works, we can then use that with AWS to verify that you do have both control of the address space and also of the AWS account that you're going to bring it into. So that ties the two things together.
We have a question here from Tech First. So can we not bring a /25 IPv4 to AWS? Does it have to be a minimum of a /24?
Yeah, so it does have to be a minimum of a /24 because these days, in terms of advertisements out on the public internet, you wouldn't be able to advertise something as small as a /25 from AWS. So we set that at a /24. So yeah, it is the minimal size that you can route on the public internet typically, and therefore that's what we're set at for that.
Cool. Yeah, big Chief Rick also mentioned he thought it was 24, so points to him.
Yeah. I mean, the technically ISPs and other network providers could choose to route the smaller blocks. It is just not common, and the global internet routing table is already pretty big for IPv4. So
yeah, so there's actually something called BCP, or best common practices, which is kind of like a little bit less than an RFC, where these kind of things are locked down. So I could look up the number. I forgot which one it is. I think like 36 or something. So BCP, whatever number it is, then spells out as like the best common practice for ISPs is to agree on a 24 for IPv4 and a /48 for IPv6. So it's kind of like we would have to convince pretty much the whole internet if you want to lower this to anything, and it's very unlikely.
Yeah, I don't think they listen to us that much.
So yeah, we have a way there that we can validate ownership of IP address space, and AS is using an X509 certificate. The other way is that we can actually do this by demonstrating that we have control of the reverse DNS for a set of IP addresses. And Christian gave you a hint of that a minute ago when he showed you in ARIN that we've set up reverse DNS for the IPv6 address space that you saw there. So the fact that you can put an entry into that DNS zone validates that you have control and ownership of it. So that's the preparation stage and validating that you do have ownership and control of the address space in the AS. We then need to set up the rowers, and we need to set it up for the IP prefixes that we're going to be bringing into AWS. There isn't an equivalent there specifically for AS numbers. A rower ties together an IP address prefix and an AS number. And it's important to say here, you don't have to bring your own AS into AWS. You can just bring your own IP address space and advertise it using the AWS or the Amazon AS numbers. So your IP addresses would appear on the internet as coming from AS16509.
Do you have to do anything different if you're going to basically be bringing your own ASN versus using Amazon's? Is there any procedural difference other than a checkbox?
So first of all, you can only validate control or ownership of an AS number using X509. There is no reverse DNS process for that validating that ownership. And then once you have validated it and you've brought it into AWS, as you'll see later on, you then have to choose to advertise the IP addresses from that AS number. So it's an intentional choice. There are some situations, and we actually had it during this session at reInvent, where we demonstrated actually advertising this block of IPs, but from Amazon's AS number. So you have the choice at that point. You effectively have a list of the ASs that you can choose.
And Code with Sean is asking, are the AWS ASNs only 16-bit? He's thinking that it's a global standard so far.
So the ones that we already have, so the 16509 is a 16-bit ASN, but you can bring in other ASs as well. So in terms of kind of global standard, there are There are 32-bit ASNs now out there and in common use. So it's not so much now that everyone has to be using the more traditional, I guess, 16-bit ASNs.
Makes cool. Yeah, sense.
So those steps that I've talked about there, the key place that you would have to work within, or the systems that you would have to work within to carry out those steps 1 and 2 are within ARIN, so within the ARIN portal. And that's what Christian's going to show you. But once you've done all of those stages, and arguably they're the more complex part of the process, the next 2 steps are done within AWS. So you now need to tell us that you are going to be bringing these IPs and this AS number into AWS, at which point it gets provisioned within your AWS account. And then finally, once you're ready to go and use these IP addresses, you will probably want to withdraw them or stop advertising them from your network and start advertising them from AWS. So the terms we use there are provisioning the address space so it's ready to go, and then choose to advertise it out to the public internet. And those 2 steps then happen in AWS.
Just for education, what happens if you don't stop advertising them from yours?
You can end up with some very interesting traffic patterns. We do actually do some validation here as well, because unless it's intentional, which it rarely is,
Yeah.
You don't want to have a situation where the same block of IPs is being advertised from multiple places. If it is intentional, it falls into the concept of something called anycast. And that is used quite intentionally for certain services out there. In fact, AWS uses it for some of our own services. So it's not to say that it's impossible. It's certainly not. It's just very unlikely that you would want to.
Yeah, Boss 73 is like impromptu anycast. Here we go.
Yeah.
And just to clarify, like in our use case, as Steve showed you earlier, we're going to bring the entire IP space into AWS. There are a lot of customers out there who choose to only bring a subset into AWS. And in this case, announcing a subset of your IP space from AWS and like still announcing the super block from on-premises is perfectly fine. And many people do this because the shorter
already stole my next question.
The shorter one wins. So yes.
Yeah. If you advertise the more specific block of IPs from AWS, that takes precedence. You just need to be careful at that point that in the on-premises environment, how are you going to route to those IP addresses yourself? Because your network might believe that they're internal. So there's kind of some interesting things there that I think all 3 of us here have spoken to customers about in the past.
Oh, yes. And then Tech is saying the BOIPs will be re-advertised to all the customers on public VIS.
Yeah, re-advertise is probably not the right word. It will be advertised. So they will become effectively EIPs or IPv6 regular space like anything else in EC2. So yes, they would also be advertised over public VIF.
Yeah, it wouldn't be doing it over and over again.
Yeah.
All right. Okay. So with this, let's have a look at the preparation. And again, as Steve said, we have 2 different ways of authenticating IP space. And we're going to show you both of them. And what I'm going to basically do is I'm going to use one method to bring the ASN in, but the method applies the same for IP space. And then I'm going to use the other method, the reverse DNS method, for an IP block. Before I do this, I'll just quickly show you basically like how to set up IPAM and walk you around. So let me very briefly do this, and then I'll come back to the 2 different methods that we have. If you could switch over to the demo. All right, so let's go into our account, and probably the most difficult step is to find IP address manager. So up here under search, you actually have to type IP and then address, and then you'll find it. So IPAM isn't good enough. That will not find it for you. So to give you an example here, IP address manager, down there we have the Amazon VPC IP address manager. Once we're in here, so I already cheated and I created one before because we will have to do a little bit of a cooking show today. We only have like 1 hour total and we already like went through 28 minutes. So we don't have enough time to do the whole thing end to end live. So we had to prepare a few things. That's why the IPAM is actually already set up as you see here. But just to quickly show you, if I were to set up a new one, the things that you can do is basically tick that box that you can do anything at all. Here are the 2 different tier levels that Steve mentioned earlier. So we will be using the advanced tier. Here is the naming. So put in any name that you want, any description, that's completely up to you. Down here, the regions that you want to operate in. And because I selected advanced tier up here, I can actually select multiple regions. So for the one that I set up, I tick the boxes on every single available region by doing the add all regions here. And that was pretty much it. So we're not going to talk about the private IPv6 GUI here. It doesn't really matter. But this is all I did, and then I hit the create IPAM. I'm not going to do this because I already did this. So that's what we have here. This is our IPAM, which is set up. So that's kind of the preparation. Let's do the preparation within Aaron. So for this one, if you can go back to the slides. Yep, so this is the first one that we're going to do. So as Steve mentioned earlier, we have two different methods to prove that the resources are actually ours. And resources in this case means either ASN or IP space. So for the ASN, there's only one method, and that is the method that we're going to use. So X509, again, can be used to prove our ownership of the ASN as well as IP space. So you see what we need to do is we need to create a self-signed X509 certificate along with the public key. The private key we keep for ourselves. That's why it's private. And we sign later a message with it. The public one we have to put into the RIA database so that then basically the AWS provisioning can find it. So that's the steps that are necessary. So what we're going to do is create the self-signed cert and upload the public key, the public certificate, and then later we do the signing. So if you can go back to the demo. So the easiest way, at least for me, is to use Cloud Shell. So already opened it up here because it has everything installed that we need. So everything is in there, OpenSSL and so on to create an X509 certificate. Now the second hardest part is all the commands to actually create the X509 key. It's in our documentation, but it's on different places in our documentation. So here's a cheat sheet. So if you go to my GitHub repo, there's the cheat sheet where the commands are just like quickly on one page, and that's what we're going to use. So you can see here the command to create a private key. All you have to do, oops, take the whole thing, copy paste it. Then we're going to head over to Cloud Shell. And run it. So that creates our private key, and it's going to ask me password.
It almost looks like ASCII art melted.
And I probably, yep, I fat fingered the password, so let me do that again.
I think it's fair to say when we talk with customers about this, this is the step that seems to worry or intimidate a few customers.
Yes.
Actually, as Christian said, once you just have the commands here, it is just a case of run through them, paste them, makes it a lot easier. So don't be put off by the creating private keys and signing things. It's actually very easy to do.
Yep. And again,
please remember your password.
Yes, and don't fat finger it. So now that we've created the private key, which a super secret, super secure password, the next step is we need to create the public self-signed, the public cert for the self-signed key. One small warning, I'll show you, there's a few information that have to go in there. It says like data does not matter, but is publicly discoverable. So I'll show you once I actually run the command what that means. So again, let me grab the command, go back to Cloud Shell, and then I'll paste it. All right, so first, our super secret password again. So now it asks me for a bunch of information that usually goes into public cert. So if you've ever created such a certificate for like a website, you know what to put in there. In this case, nothing that you put in there matters, except you're going to put that public key up into the Aaron database where other people can find it. So if you try to be very creative on stuff like this, just keep that in mind. And yes, I created all the certificates for the documentation, and I really had to restrain myself on the creativity. So I'm going to put in my home address.
This is where we can all send you mail.
Yeah. If you want to, I can put in the PO box. Okay, that's it. So now we have the this self-signed certificate. And again, you see the last step is then just to like output this public certificate. And there we go. So now is, again, one step where you could make a mistake. We need to crop the certificate, and it has to be from where it says here begin certificate. So from all the way to the beginning to all the way to the end. So up to here, the last dash. That's
Do
it.
not grab your prompt.
Exactly. Do not grab your prompt. Do not like strip off the begin certificate, anything like
Right.
this. So that's all we need. So now I'm going to go and say copy. That's it. So with this armed, we head over to our errand portal. And you remembered we had the ASN up here. And it looked like there wasn't really anything to do there. But there actually is one thing. So on the action, we can say modify. And here's the public comment field. And that's where we're going to put the key in there, the public key. And again, it's like, don't try to add any new line characters, anything like this. So the whole thing has to be staying like this. One big blob. And that's basically is. If we would be doing the same thing for an IP address space, it would look pretty much the same thing. So just to quickly show you, if I go to one of the IP address spaces, let's say the IPv6, similar thing here under action, modify, there is this public comment, and then we could put it in there just the same way. So that is effectively how you create the self-signed certificate. You use the public key, you upload it, and that's it. So now for the first step, we have done everything we need to do. We prepared that we have control over this one. And you see later this like sign auth message that comes later when we actually try to provision it. So if you could quickly go back to the slides, then I'll go over the second method. So the second method is to use the DNS reverse zone for DNS TXT record. And that one is a little bit easier because you don't have to use Cloud Shell and like create a self-signed certificate. What we basically give you like a key from within IPAM that you just put into DNS. The drawback is you have to set up reverse DNS. Many people don't do this. So in this case, you have to set up reverse DNS. So we often get asked, it's like, which of the two methods is easier? Or which one should I use? It really depends on you. So if you have the choice, as with IP space, pick whichever makes sense for you. If you don't have the choice, well, then you don't have the choice. So in this case, I'm going to use this method in order to authenticate our IPv6 address space. So if you could switch over to the demo. Okay, perfect. So in this case, what we're going to do is we're going to quickly go and create our pool for the IPv6 address space and then authenticate them. So let me do this. So again, like I mentioned, we have a little bit of a cooking show. So we already brought the IPv6 space in it. Now I'm going to do the same thing with the IPv4 space. So for the IPv4 space, let me create a new pool. And you see it's under the scope public because it is for public IP space. For the comments, I'm going to quickly just copy paste. Okay. So we're going to call this global IPv4 pool. It is IPv4. And this one is going to be a global non-regional pool. So the idea is like you have one global pool that is not assigned to a region, and then you can basically subdivide it and the subdivision assigned to an actual region. So that's why here under locale, for the first step for the global pool, I'm going to choose none. And then you see we come down for the provisioning steps. I should put in the actual IP space at one point. Okay, so here we go. Here is where we have the two mechanisms, and I'm going to show you the input via the DNS text entry. So the first one is I actually have to put in the IP space. And then down here it says under DNS TXT record entry is to select the token, but there is no token right now because we haven't created one. So the first step is then to actually create a token. So there we go. There is our token. And you see down here are the two different values that are shown, and these now have to be used with the reverse DNS zone. So for this, let me grab the first one, the token name. and head over to our reverse zone. So as I mentioned before, we are using Route 53 for our reverse zone. So here we go. And just the nature that reverse zones work is the reverse zone for our /23 actually consists out of 2 zones of size /24. That just like DNS reverse zones is basically bound to the to a /24 boundary. If we had like a /16, it would be a /16, but in this case we have 2 /24s that make up the /23. So I will have to create that record in both of them. So that's why you will see me doing the same thing twice. So we go into our first subzone and we create a new record. And again, the hardest question is like, what record type? And if you remember, that whole thing is called DNS TXT record authentication. So that should give you the hint. We need a TXT record. Then the value that I grabbed was the name. So we put the name there. Then let me go back. And the other one was the value. So token value is the value. So name goes into the name, value goes into the value, and the type is TXT. That's it. Then I can create record. And as I mentioned here, we have the record at the bottom. And as I mentioned, we have to do the same thing. Oops, we have to do the same thing twice. So I'm going to grab again the name. Go back to my second zone and do the same thing. So text record, name, value, and create record. So that's it. So now we're ready to hit the create pool. You can put in tags if you want to do any of the other advanced features, but that's all we're going to use. So we just selected the name. We said that it's a global pool, so not localized, and we put in our authentication. So with this, create pool.
So we do have one question
Sure.
from Tech First about IPAM. Is local only available on advanced tier?
It is also available in the free tier, but it makes less sense because in the free tier, you're restricted to one region. So you're not going to create a global pool and then split it into multiple regions. You're still free to kind of like create like the root pool and then like split it down, but it makes less sense. Unless you want to plan in advance and kind of say, let me do it anyways, create a global one, create a regional one, because in the future I might upgrade from the free tier to the advanced tier. So that might be one reason why you might still follow the process that we have shown here.
Makes sense.
All right. So now we have basically like provisioned the CIDR. So in this case, you can see it's kind of like the 2 steps are already like intermingled. Versus on the other one where you use the X5 certificates, we actually have to like finish the step there. So we did the preparation again, like for the DNS, it was kind of like intermingled. But for the other one, remember we didn't actually provision the bring your own ASN yet. So let me finish that step and go to the IPAM. And then here you can see is a tab for bring your own ASN. Don't get confused that the number is already in here because we ran through this demo more than once already. So that's why we kind of like provision it, deprovision it. So it shows up it is currently being like it is deprovisioned because we used it before. Usually this would be empty. So let's start with provisioning that bring your own ASN space again. And you can see the first thing it asks is for the ASN number. And here again, it's like the number 1 mistake that you can make. I'll find my mouse, is that you actually put an AS in front of your AS number because it's like what many places show it. But it only wants the where is my mouse? It only wants the actual number. And the wonderful thing, it will buffet you all the way at the end if you put the AS in front of it. So just keep that in mind. The next thing is it shows you a message here and it wants you to sign the message. So it asks you like, what is the signature for this message? So that is the part that I mentioned earlier. We have to sign this message with our private key. And again, the trick is go to the sheet and see what you need to do. So first we have to construct our message that needs to be signed. So text message equal There's my cloud shell. Let me make a little bit of space so that we see more. Okay, so that's our text message. Now we take the actual message and at the end. Okay, so that's all we had to do is define the message. And now we're going to sign the message. So this command here again is like, we could go over like in detail what it means. It just like, it takes the message that is like stored, strips out all the new lines that could accidentally be gotten in there, and then uses OpenSSL to sign it. So we'll use this one to sign the actual message. And again, it asks us for our password. And there we go. And then the last step is, again, I'm too lazy to type, is to print that signed message. So that's our signed message that we have to grab fully and put into this field. And again, just quickly, so one of the typical things that you might have done wrong is like here where you assigned a text message is that you did not actually correctly assign the text message. So that's why we can print out the text message and you see there's actually something in there. So that is basically like, yes, it will gladly sign you an empty text message. So that's the thing. It's like, what could happen is like that the system barfs at you and says like, no, something is wrong. It's like, yes, you gave it an empty text message. So that's it. Now we click on provision and then the whole thing will kick off, take a while and provision our ASN for bringing your own ASN. So we can go here, have a look. So that one is going to take a little bit of time. We can go back into our pools in the meantime and see if the pool is being provisioned. So this one is readily provisioned, but it's a global pool at this point. So now what we need to do, or what we want to do, is we actually want to create a local pool. So for this one, we can say create pool within this pool. So out of this 23, we're now going to create a subpool, and I'm going to give it the name. Let me grab the name that I had prepared. So we're going to create a subpool for IPv for US East 1, which means that once I scroll down here under locale, I'm better going to use US East 1. There we go. Now the next step, what you could do incorrectly is here where it says is like, what do you actually want to use that for? Right now, none, which would mean it's like we cannot actually use it as a leaf pool. We can't do anything with that other than like create another pool inside of it. But that's not what we want to do. We actually want to assign EC2 addresses with this. So in this case, it's an IPv4 pool. We want to assign EIPs out of it. So that's why we need to make sure that we tick this box here. Now the next step is like, which size of the pool do we want to use? So that's why I could either choose here a CIDR length, this one, or I could actually enter the CIDR itself. So I was lazy, I just picked it. So you see we had a total of /23, and we basically used the lower half, which is this 24. And that's it. And again, like you can put in tags whatever you want to, but you don't have to. So with this, let's create the pool.
Although we strongly recommend that you do tag it so you know what's going on, human readable, all that fun stuff.
Correct. All right, and then we can see here it's still pending provisioning. So that's the things where kind of like we had to do the cooking show because a lot of these things just takes a little bit of time. And it has to run through. So now we have to go back and do a little bit more preparation while this stuff runs through. If you can go back to the slides, and then I'll show you the two more things. Okay. So one of the things is kind of like more like a trick to keep in the back of your mind. When you deal with reverse DNS zones, it's sometimes hard to like keep in the back of your mind how big that reverse DNS zone is for IPv6. For IPv4, it's pretty easy. You see, this has to be as an octet boundary. That's what I mentioned before. So the /23 is broken down into 2/24s. On the IPv6 side, it's at nibble boundary, so like multiples of 4. So in our case, it's pretty easy because we use the /40, so we're lucky. We had one big zone. But if you had a /42, you actually have to break it into 4/44s, and then I would have to repeat these steps 44 times. The other thing is, like, when you actually look at this record name you see up there in that screenshot, to see it's like, did you actually create that record at the correct length? Is like count the characters, multiply it by 4, and the number that you get should be the size of the zone that you have. Again, it's also in our documentation, and when I created the examples for the documentation, I did a few mistakes, so I had to like go back and correct it. So that's why this little hint is in there. If you can go to the next slide. So now we want to finish our setup within Aaron, and one of the things to do here is to set up the ROA. So that's the one that also Steve mentioned very at the beginning, is to basically show it to the rest of the internet that we are authorized to announce the space. We put all the information that we need on this slide here. So the different ASNs that might need to be authenticated is like, if you bring your own ASN, you still have to authenticate it for the commercial side. So in this case, 16509 plus 14618, in addition to your own ASN. That is how it is, because in theory it could still be could still be announced from this ASN, so that's why it needs to be in there. If you're doing all these steps that we're showing you now in the commercial region in GovCloud, then there's a different ASN that you need to provision. So with this, if you can switch over to the demo again. And I'm going to head back into the Aaron portal. Oops, sorry. And under routing security, you find manage RPKI, because we're actually using the hosted RPKI from Aaron. So we're not using our own RPKI. That's the easiest way. It could be that your company is using their own RPKA. In this case, it will all look a little bit different. So if I look at the rows that are currently already created, some of them are already in here. So I created a bunch of them. Down here is one for the demo, but it's currently missing the one for, you see the IPv4 range. So I'm going to create this one here. So let me just grab this one. So create ROA. So what it asks me is our ASN. Let me grab the one again, because I don't remember that. All right. So the ASN, which is allowed to originate this IP prefix, the prefix itself, and then the max length. And max length, we ask you for an IPv4, it should always be /24. And for IPv6, it should always be 48. So kind of like the minimum size that it could be. Row name, put in whatever you want. IP. And that's it. So here's one thing that, funnily, Aaron added the week before we did this demo at reInvent, is they have the capability that when you create a raw entry, they can automatically update the IRR with it. So that's all it does. It basically says like, yep, go create the corresponding IRR object. Otherwise, you would have to go and do this manually. Good thing, saves you time. So that's what we're going to let it do. And here we go. So now the question is like, what's the difference between this raw entry, which has one ASN and 2 prefixes, versus me doing it 2 here separately? Actually, no real difference. The only thing it's like, if I would like decide to sell off the /24, the IPv4 space, the /23 here, I would have to basically like break this apart and like create 2 separate ones. Versus here, I could just like delete one of them. So that's the thing, is like you can individually manage it here or like manage it as a chunk. We're not going to sell off the IPv4 space, so it doesn't really matter. So that's all we need to do within our Aaron portal. And with this, we have pretty much all the preparation steps in place. So now we can go back and hopefully, given that we did a little bit of kind of like out of order provisioning, see if everything is in place and if we can start announcing the address space. So let's have a look in which states our different pools are. So we have here our global IPv4 pool. Sorry. So that one is readily provisioned. We have our leaf pool. That one is also provisioned. You see right now it's not showing any bring your own ASN association. So that is the part that we still need to do. But before we go there, let's have a quick look at our ASN. If it is also fully provisioned. Yes, it is also fully provisioned. So we're actually able to do everything live today. So let's go back to the pool. And in this case, we have to manage the bring your own ASN associations. So here we can now pick that ASN that we provisioned earlier and associate it. So once this runs through, this IP space can be announced from either the AWS 16509 or from the bring your own ASN that we're currently associating. So let's hope that goes through pretty quickly. And there we go. So everything is in place. So we're pretty much ready to announce our space. There's one thing that we want to do. We want to see something. Like if I just hit that button and like it will tell you it's announced, you shouldn't really trust me. You should like be able to like validate it. So for this, what we have is there's a web page called RIS Live from the RIPE NCC, and it basically has a bunch of probes all around the world where you can see routing updates. So what you see right here is a whole bunch of routing updates from these different hosts. And we want to see if in these routing updates, we see our announcement, like our IP space that is being announced. So for this, what we want to do is we're going to first select all of the probes out there, but we want to restrict it to our prefix. So going back, it's like we're going to use this prefix here, the /24. That is the prefix that we want to listen for. So here under prefix, we're going to put this one in. And the other one, let me see, what else did I want to set?
We've got a few folks that are also watching for it as well.
It's like all eyes are on this prefix, isn't it?
All eyes are on the prefix. Dominic, do you see it yet? He started looking before Christian did.
All right, there we go. So now it actually has subscribed to it. So I clicked on updating it. So now you don't see any messages anymore because now you see it's like we're only looking for this one particular prefix. So with this, let's quickly go back here and advertise our space. So we can see right now it is withdrawn. And I'm going to say advertise. So here's another thing which sometimes in the eagerness of like, let's advertise our space, we forget to do. We actually have to say from where we're going to announce it. So in this case, we want to announce it from the bring your own ASN. It's not in here yet. Let me quickly try to refresh.
Uh-oh.
Like we didn't correctly set up the space. Let me advertise it from 16509 so that we see something at all. All right, so I'm going to hit the advertise button. And then let's see how long it takes until something actually shows up here. And hopefully before we have to wrap up, something will show up. There we go. So it is actually advertising. So I might have fat fingered the ROR at one point, or it could be that the timing wasn't just right. It only updates at certain intervals. So that's why we couldn't do it with the bring your own ASN. And I think we are out of time.
Yeah.
So we have to wrap it up.
There we go.
I think the one thing I would just say there is obviously we've done that in an hour. The reality of doing this is that you would spread this over a couple of days. So we did manage to get it all done there. We have advertised it. That was real. But doing this with customers, this would normally be done over a couple of days and done very carefully.
Yep.
Well, folks, this is it. We got it all in. That is awesome. Steve, Christian, thank you for coming. And folks, if you go to reInvent, they're always there, as well as Reinforce is a possibility. And again, if you have missed this episode or missed any portions, you can go to theroutingloop.net where we will have this recorded session. You can give it all to your friends and family. Thank you again, and see you all later.